So today we would look into yet another very important data structure called as the queue data structure, right? Called as the queue data structure. And you experience queues in your daily lives. For example, you experience queues at ticket counters, you experience queues when you submit your examination forms or forms for various jobs at the form submitting windows, right? You experience queues at the doctors' clinics, and you experience queues at banks, etc. And you know, in a queue, people line up in a way that the person coming first gets serviced first, and the person coming last would get the service last, right? And the same mechanism or working principle is used in these queues, right? Queue data structures, right? So a queue, if we technically are to define a queue, then we say a queue is an ordered collection of items, right? Ordered collection of items, right? And then number two most important point is that, for example, see this image, right? See this image, right? So we say a queue is an ordered collection of items, right? So by ordered we mean that you can say that this item, the place occupied by an item, this place, we will call it as the first place, and this would be second, third, fourth position, fifth position, and so on. Okay, so then the next most important point is that in a queue data structure, items are added at one end of the queue, at one end of the list, right? And the end at which items are added, that is called as the rear of the queue, rear of the queue, right? And then items are deleted or removed at another end of the list, right? And that end is called as the front of the queue, front of the queue, right? So this queue is also a list data structure. That's why I have used this list term, right? Because as the items of a list are arranged sequentially, the items of a queue are also arranged sequentially, right? So, but then in case of a stack, the addition, insertion, and removal or deletion of an item was done from the same end of the list. But in this case, in case of a queue, additions are done at one end, called as the rear of the queue, and then deletions or removals of the items are done at another end called as the front of the queue. For example, take this picture. So this is the rear part, right? Imagine this is a doctor's clinic, right? Imagine this is a doctor, right? Imagine this is a doctor. For example, he is Dr. Zing, right? Then people arrive to get examined by this Dr. Zing from this end, right? So the person arriving first, let us name that person as 1. He comes from this end, and we make him sit here at position number 1, right? This is position number 1. Then the second person comes, so naturally he gets this seat. Third, he gets this seat, and so on, right? So they arrive, they get added to this queue list structure from this end, called as the rear end. And then once the doctor calls in the patient for examination, the person coming first, that is this, would get the service first. Once he gets service first, he will leave first, and he will leave from this end, since he gets service here and he leaves, right? So we say deletions or removals. Once this person gets the service, then he is removed from the queue, and this is advanced here, this gets here, right? So we say a queue is an ordered collection, right? Ordered collection of items wherein insertions are done at one end, that is this end, and removals are done at another end, that is this end. And the mechanism of operation is first come first serve basis, that is the person arriving first would be getting this service first. And technically, in technical parlance, we name that mechanism as first in first out, since the person coming first would be the first to get removed, right? So that's why we term this as first in first out data structure also, right? So this is how this differs from the stack data structure, right? And then the operations, let us talk about the operations which can be done on a queue. As already told, we said 2 operations can be done on a queue. One is insertion. Or addition, okay, of items. And technically this operation of insertion or addition of items is called NQ, right? This is called as NQ operation. And another operation which can be done in case of a queue data structure, it is the removal, that is deletion or removal of items, right? And technically this thing is called as the dequeue operation, right? So this thing, removal, is called dequeuing, and insertions are called enqueuing operations. So these two operations can be done, but then we have to remember that this enqueue operation is done from the end, which is called as the front. Okay, and this dequeuing operation is done from the this enqueuing operation is done from the this is done from the rear end of the list, and this dequeuing is done from the front, right? So these two things you will have to remember, right? Then in case of, and keep this image in mind, this is the rear end. So this, at this end, what happens is enqueuing. Okay, and this is the front. From this end, what happens is dequeuing, right? So now in case of the linked list implementation, in case of the linked list implementation, as is obvious, once we say enqueuing happens from the rear, that is the wait, in case of, assume this is a linked list representation, assume this is a linked list representation, right? So these are the nodes representing items. Okay, so imagine this is the linked representation of a, so this is the, imagine this is the head pointer. Okay, so this is the beginning, this is the beginning, right? And this is the, this will point to null because this is the end, okay, of the linked list. Now see, imagine this is 1, this is 2, this is 3, this is 4, and so on, right? So once we say enqueuing happens from the rear part, so then keep this representation in mind, and then once we say first in first out, that's node number 1 comes in first, so this will be the first node to be deleted, right? And so on. So the next node which comes into this queue, example node number 5, that the place for insertion of that node will be this end, that is insertions are done, insertion of a new node, that is insertion of a new node will happen from the end, and the removal or deletion of a node will always happen from this end. We call technically that's the end, that end as front, but then in case of linked lists, we know that the node to be removed, the removal always must happen from the beginning of the list. So removal must happen from the beginning of the list. Now this problem reduces to a very basic problem of insertions and deletions in a linked list. So the only thing you have to remember is that in case of the linked list implementation of a queue, only 2 constraints are to be enforced. And what are those constraints? Constraint number 1. Insertion of a new node must always happen from the end. And what's constraint number 2? The deletions of a node must always happen from the beginning of the linked list. And we have already taken care of these operations, that is insertion from the end and deletion of a node from the beginning of a linked list. We have already taken care of those two operations programmatically, so there is no fun in writing those programs again. So I would expect from you to write those two functions, that is removal of a node and insertion of a new node, of course keeping these two constraints in mind yourselves, because we have already done that. You just have to name those two functions as NQ and DQ, right? So I suppose that it will be easier for you to do, because no point in wasting time in discussing things which we have already discussed in very fine details. So this is all. Thank you very much. This was about the queue data structure. Thank you very much. Go through this once again and then try to write the code. Of course you can take help from the code we have written for these two operations. Thank you very much.